In the last video lecture, we learned how to use Venn diagrams in order to prove whether or not a categorical syllogism is valid or invalid. In this lecture, we're going to look at this in more detail and survey some more complicated examples. The last time what we did is we just looked at arguments that were presented in the following form: all S are P, all S are M, all M are S, therefore all S are P. We looked at these that are presented with these symbolic notations. And this made it easier to diagram because we didn't get confused over the language that was being used. Ultimately, however, we're not going to really encounter many arguments like this in life. You're not going to pick up a newspaper and read an argument that's in symbolic form with S's and M's and things like that. And so you're going to encounter arguments that are going to be in ordinary English, and it's going to be important that you're able to determine whether or not one of these is valid or invalid. And we're going to actually use a number of skills that we've worked on in the past, and we're going to combine those. We're going to be combining diagramming arguments, also with distilling arguments, and also with putting arguments into symbolic form, or I should say standard form. We're going to be adding another skill, which is being able to use an argument in standard in plain English, but is in standard form, and then put that into symbolic notation, because I think that makes it easier to diagram the arguments, to translate it into symbolic notation. Now let's just get started. We're just going to do a couple of examples of this, and then I'm going to let you loose and do some homework. But take the following argument, for example. No horned animal is a carnivore, all moose are horned animals, and no moose is a carnivore. Now this is a pretty simple argument, but how would you go about diagramming this argument? Well, it gets, to me, it's kind of confusing. You could, if you wanted, just go ahead and draw your Venn diagram for the argument, draw your three circles, and then you could proceed from there. And you might use notation to represent the various terms. Like you might use, for instance, a C to represent your major term down here. Maybe you'd use HA to represent horned animals. Maybe you use M to represent moose. But to me, it gets a little jumbled and confusing when you do that. So what I like to do is, when I'm trying to determine whether or not an argument like this is valid or invalid, I like to translate it into symbolic form. And in order to do that, we have to identify the three terms that are used: the major term, the minor term, and the middle term. And in this argument, I'm just going to walk you through the process of translating this into symbolic notation for the purpose of ultimately diagramming. You'll see how all this works together. So first thing I'm going to do is locate the major term, which is right here. And I'm just going to use the letter P to represent carnivore. Carnivore is our major term here. Or I guess I should say a carnivore, if I'm to be technical, but it doesn't really matter. I'm going to use a P. You could use any letter you want it, but just, for purposes of consistency, I'm using P. Then I'm going to identify the minor term, which is moose, and I'm going to use S to represent that. And then finally identify the middle term, which is horned animals. And then once you do this, you can see that the argument being presented here is of the following form: no M is P, all S are M, and no S is P. And then once we've done this, then we can go on to diagram the argument. And I'm going to do that for you right now. It's just, to have a little more practice doing this. But we're going to diagram this argument. If I can get my app to come up on the computer here. Okay, there we go. All right, and what I'm going to do is just, let's see if I can get this thing to cooperate. Apparently not. All right, there we go. That'll have to work for right now. Actually, it's not working for right now. That doesn't work for me, people. All right. So there we go. So I'm going to just leave the argument right here off to the side so we can see it. and then we're going to do our Venn diagram over here. And what we do when we do our Venn diagram, of course, is we come up with our 3 circles, and we mark those circles. We number the regions. We have region 1, 2, 3, 4, 5, 6, and 7. And the first thing we do is we diagram the combined premises. And you might remember that, and I'll write this up here just so we can see it. No M is P. And M, oh sorry, I forgot to put these in. We put these in. And M is equal to region 1, 2, 3, and 4. And P is equal to region 3, 4, 6, and 7. So the first thing we do is we're going to diagram the premise number 1. And so 1, 2, 3, and 4. And we'll do 3. I'm having trouble with the 3's, aren't I? 3, 4, 6, and 7. And as you recall, what we do is we identify the regions of overlap. So in this one, it's region 3, right, and region 4. And then we scribble this out. And then since it says no, what we do is we shade in 3 and 4. So we'll shade in 3 and 4 down here. And then we come to our second premise. We're going to do that. All S are M. And S is equal to region 2, 3, 5, and 6. So we'll write that right here, 2, 3, 5, and 6. And then M, as we've already said, is 1, 2, 3, and 4. All right? And then we locate the regions of overlap, which is going to be 2 and 3. And then we can scribble these out. We don't care about those. And we're saying that all the S are in 2 and 3. So they're all hypothetically in 2 and 3. So where are they not? They're not in 5 and 6. So we shade in 5 and 6. So that is our diagram of the combined premises. Now what we do is we come over here and we're going to diagram the conclusion. So let's diagram the conclusion. So let me erase this. All right. And just like before, we're going to put our S here, our P here, and our M here. And then we're going to 1, 2, 3, 4, 5, 6, 7. And we're saying for the conclusion, no S is P. So we come down here, region S is 2, 3, 5, and 6. 2, 3, 5, and 6. And P is 3, 4, 6, and 7. 3, 4, 6, and 7. We circle the regions of overlap, which is going to be 3 and 6. And then we can scribble these out. And we're saying no to 3 and 6. So we're going to shade in 3 here, and we're going to shade in 6 here. And then what we do is we ask, are the regions shaded in this diagram? Are they also shaded in this one? And the answer to that is yes. And so this is a valid argument. Like we said before, you can shade more in the combined premises, but you can't shade less. Since 3 is shaded here, 3 has to be shaded here. Since 6 is shaded here, 6 has to be shaded here. So this argument is indeed a valid argument. All right, well, let's look at some more examples of this. So here's a more complicated example that we can do, but hopefully you've seen how the first one works. And basically what you are doing, as I said, is, for me, when you get a more complicated example like this, it's just tricky for me unless I first translate this into symbolic notation just so that I can do the diagram. I mean, it's not a necessity, but in my mind it makes it easier. So the first thing we have to do is identify the 3 terms, the major term, the minor term, and the middle term. And I'm just going to begin by identifying the major term, and it is person or people who were elected to Congress. So that's our major term, and then we're going to identify our minor term, which is candidates who favor strong governmental regulation. And then finally we're going to identify the middle term, which is member of the Green Party. And then once we do this, hopefully you can see that the form of this argument, if you look here, is saying no M is P, some S are not M. I know I had to put my M down here. It's a little confusing, but I couldn't stick it in between that line. And therefore, some S are P. And so here's the argument. No M is P, some S are not M, some S are P. And we want to figure out if this argument is valid. And hopefully I didn't go over that too quickly, but basically what you're doing, like I said, is you're identifying the three terms, the middle term, the minor term, and the major term. And we do this for the purpose of Venn diagramming. Now, what we're going to do is go ahead and Venn diagram this argument, since we've put it in a symbolic form, just like we've Venn diagrammed all the other arguments. Hopefully it's becoming familiar to you at this point. And we begin by getting our three circles. We identify our three classes, S, M, and P, and we number the different regions. Now, as far as Venn diagramming this argument goes, we begin, just like always, by diagramming the combined premises. And as far as this goes, we could begin with premise 2 if we want it. But as I said, it's just a good policy for, basically practical reasons to always begin by diagramming the universal premise first, if we have a universal premise. So you could have an argument that has two particular premises. I'll go ahead and tell you, no argument that has two particular premises will ever be a valid argument, but in theory you could. And we're going to begin with the universal one just because this tells us more definitive information. So we begin, no M is P, and we identify the regions that are equivalent to M, which is 1, 2, 3, and 4. And then P is 3, 4, 6, and 7. We identify the regions of overlap, which are going to be 3 and 4. And we scribbled that out. We don't care about that. And it's saying no to 3 and 4. And since it's saying no to 3 and 4, we're going to shade in 3 and we're going to shade in 4. Next we come to our second premise. This is a particular negative, but it's particular nonetheless. And it's saying some M, I'm sorry, that is not accurate. It is saying some S are not M. And S is 2, 3, 5, and 6, though I've scribbled over the 3, but it's still 2, 3, 5, and 6. And M is 1, 2, 3, and 4. 1, 2, 3, and 4. And what we do is we identify the regions of overlap, which is going to be 2 and 3. And then we can scribble out 1 and 4, though I did that completely backwards. Now what this is saying is are not. Pay attention. We know that since we have some, we're going to use an X. Remember, we always use an X for some. We only use shade for all or no. If you see a universal quantifier, all or no, you're using shade. You see the word some, you're using the X because X means exists. All right? So we know we're using an X, and our question is what region do we put it in? And it's saying are not in 2 and 3. That means it must be in 5 and 6. Now, we look down here, and neither of these regions have been excluded. Both are on the table. So we could put an X in 5, we could put an X in 6. And whenever that occurs, what we do is we put an X right on the line, which hopefully all of you remember now. So this right here represents the combined, or the diagram of the two combined premises. Now what we want to do is diagram the conclusion. So we're going to, oh goodness, we're out of room trying to figure out where I can put this. Put this up here, and then we S, M, and P just like before. 1, 2, 3, 4, 5, 6, 7. And our conclusion says some S, R, P. And just like before, S is 2, 3, 5, and 6. We identify the regions 2, 3, 5, and 6. And P is 3, 4, 6, and 7. 3, 4, 6, and 7. We know we're using an X because of the word sum, so we identify the regions of overlap, which is going to be 3 and 3 and 6 and 6. We can scribble out the 7, we can scribble out the 4, and we're saying R. Sum R and 3 and 6. So it could go in 3, it could go in 6. We put an X right there. Now what this is telling us is the conclusion is true just in case the combined premises definitively place an X in either 3 or 6. If the combined premises over here, if they definitively place an X in 3 or 6, then the argument is valid. But notice that they do not do that, because the combined premises are telling us we don't know where the X is. It could be in 5, it could be in 6. And so for that reason, this argument is invalid. This argument is invalid. So you see how we began with this common, or this argument, this in ordinary language, and we were able to put it into standard form. Actually, I did that for you. Put it into standard form and then put it into this symbolic notation that I have down here at the bottom, and use that symbolic notation in order to determine whether or not the argument is valid. Now, quite often you don't encounter arguments that are this nice and neat for you, and you're going to find arguments that are that just flow a little bit better. You know, maybe if you read a newspaper or someone presents it. So I'm going to give you an argument, and I want you to try just very quickly to see if you can't put this into symbolic form. So I'm going to ask that you pause the video lecture just for a minute and put this into symbolic form, and then to determine whether or not this argument is valid or invalid using Venn diagram. So go ahead and pause the video lecture and do that very quickly, or however long it takes you. If it takes you not so quickly, go ahead and do that. All right, well, hopefully you did what I asked you to, and you tried to put this argument into standard form, and you tried to go ahead and determine whether or not it's valid or invalid. This argument's a little bit tricky, and the first thing we do whenever we're trying to put an argument into standard form is we have to distill the argument, and that means we have to determine what the conclusion is. Now, this one had a couple of indicator words to let you know, and you might have saw this word here and seen this word thus, and thought, the conclusion is a minimum wage is nothing more than a price control. But if you started with that, the argument didn't really work. And so that right there is not the conclusion. There was another indicator word that you should have seen, which is so. Now this is kind of tricky here, because you're looking at this and you're like, wait, how can we have two conclusion indicator words and only one conclusion here? I mean, is this going to work when we have two conclusions? No, this is taken from a passage, and you can see that this thus is linking this entire argument that starts from a minimum wage. It begins right here. It's linking all of this to something that must have come on or been said before. So this thus is not tipping us off that this first sentence is the conclusion of this argument that's being constructed right here. The word so is actually telling us what the conclusion is. And the conclusion of this argument is a minimum wage must be harmful. Now, if this is all we have here, notice that this proposition is not in standard form. There's no quantifier, there's no copula. Must be harmful. That doesn't name a class. So we're going to have to put this proposition into standard form. And we're going to say something like the following. All minimum wages are harmful policies. You might have said all minimum wage policies are harmful policies. You might have said all minimum wages are harmful things. You couldn't just say are harmful, because harmful doesn't name a class. You need to say harmful policies, harmful things, harmful actions, harmful practices, something so that you're naming a class in the predicate term. But notice that now, go back a slide, here we lacked our quantifier, we lacked our copula, and we didn't name a class in the predicate term. Now we do. We have our quantifier, we have our copula right here, and we're naming a class, harmful policies. Now, I'm going to begin by identifying the other premises, and I'm going to start by doing something that I don't typically do, and I'll make it clear why that is. But I'm going to try to identify the minor premise next. And I'll be clear about why that is later on. I mean, truthfully, you could identify the minor premise first. I always go with the major, just, I don't know why, it's just habit, but there's no logical reason to do one over the other. But notice what our minor term is, which is minimum wages. Now let's look up in the argument above and see if you see the word minimum wage anywhere. And yes, there you go. The very first sentence, a minimum wage is nothing more than a price control. So we know that this is going to be the minor premise, right? Because the minor term is right here, and the minor term occurs in the minor premise. But notice that this is also not in standard form. We don't have our quantifier here. And also, nothing more than a price control. That doesn't name a class. Now, you might see this word nothing and you think, oh, this is negative. But truthfully, it's not. I mean, at the end of the day, what this is saying when you say a minimum wage is nothing more than a price control, all you're really saying is all minimum wages are price controls. Look at that again. A minimum wage is nothing more than a price control. The nothing more is not negating this proposition. It's not doing that. It's really just saying when you say nothing more, you're just saying a minimum wage is merely a price control. That's really and truly all you're saying. This is not a negative claim here. It's not a universal negative. It is saying all minimum wages are price controls. All right. So now that we've identified, our minor premise and we have our conclusion, we have to identify our major premise. And this is why I held off on this, because notice right here we have this term, harmful policies. Now if we look up here, thus a minimum wage is nothing more than a price control. Price controls have always been disastrous, so a minimum wage must be harmful. Do we see harmful policies? No, we don't see harmful policies. We don't even see the word harmful. But what we do see is a synonym for harmful, which is disastrous. So since disastrous and harmful basically mean the same thing, I can't really think of, or at least in this particular context, I don't see any significant reason to draw a big difference between the two. And for that reason, I believe that price controls have always been disastrous, that this is our major premise. Now, just like before, we don't have our quantifier here. And the terminology is a little different. Our major term is harmful policies. So we'll need to drop disastrous and we'll need to put in place harmful policies just so that we're consistent with our terminology. And we also need to add our copula as well. So basically we need to put this proposition into standard form. We need to have our quantifier, our subject, our copula, and then we need to have our major term right here. So it's just going to be something like this. All price controls are harmful policies. And that is basically the argument that is being made here. All price controls are harmful policies. All minimum wages are price controls. Therefore, all minimum wages are harmful policies. Now, oh, sorry, I clicked too fast. Now what we want to do is we want to be able to determine, is this argument valid? Yes or no? By the way, what is the mood of this argument? It's pretty easy. AAA. What is the figure? Well, the figure is figure 1, right? And the figure is figure 1. We see the price controls as our middle term here. Now, I'm going to just show you a shortcut for putting this into symbolic notation. Earlier, I kind of walked you through the steps, but the truth is once you've identified the middle term, it's actually, if your argument is in standard form, if you have your major premise first, and then your minor premise, and then your conclusion, all you really need to do is identify the middle term, because then you know that this term right here is going to be a P, and this term right here is going to be your minor term is going to be S, and then S comes first in the conclusion, and P comes second. So once you've identified your middle term, it's really just a very simple process of putting it into symbolic notation. You know, earlier I was like kind of walking you through it just so you could see it. But if you want to save yourself some time, just identify the middle term, and then you know P comes in the first premise, S comes in the second premise, and then in the final, and then the conclusion is going to be S and P. And then you just got to translate your quantifiers over here without getting those out of order. And so here is our argument that we have symbolized. All M are P, all S are M, all S are P. Now what I want to do, just so we can get a little more practice, is we're going to, just like before, we're going to diagram this argument to determine whether or not it is in fact valid. And you might have already kind of guessed that it is, but you know, we need to practice these things just so that, you know, we can get more proficient at it. All right, so let's diagram this argument. And like all diagrams, we're going to begin by drawing our 3 circles and labeling S, M, and P. And 1, 2, 3, 4, 5, 6, 7. All right, we do that. And then we were going to begin, we can begin with premise 1, which says all M are P. Now M is 1, 2, 3, and 4, and P is 3, 4, 6, and 7. And we identify the regions of overlap, which is 3 and 4. 3 and 4, we get rid of that. And we're saying all are in 3 and 4. So they're all in 3 and they're all in 4. But if all of the M are in 3 and 4, where are they not? If they're all here, there's nothing in 2 and there's nothing in 1. Remember, and I didn't say this before starting, whenever you see all, know that you're using shade. And, you know, just if this is confusing to you, if the diagrams are still confusing, just notice that you always shade, when you see all, you always shade in the regions in the subject term that you didn't circle. You always shade in the regions that aren't intersecting or overlapping with the predicate. So that's the way it always works. If this had been a no, we'd shade in the regions we circled right here. But since it's an all, we shade in the regions we didn't circle. That's the way it always works. So if, you know, that helps you, sorry it's taken me so long to put it that way, but anyways, hopefully at this point you're kind of getting the swing of this. So all S are M. Now we're going to shade or do the second premise. So S is regions 2, 3, 5, and 6. And M, regions 1, 2, 3, and 4. So we circle the regions of overlap, which are 2 and 3. We don't worry about that. And just like I said, we're going to shade in the regions we didn't circle. So we're going to shade in 5, and we're going to shade in 6. All right, so now what we do is we come to the conclusion. This is what we're going to do last. And just like before, I didn't give myself enough space. So we're going to do the conclusion. And we're going to SMP 1, 2, 3, 4, 5, 6, 7. And the conclusion says all S are P. And let's see, S is region 2, 3, 5, and 6. And P is 3, 4, 6, and 7. And we circle the regions of overlap, 3 and 3, and 6 and 6, and we scribble out the 4 and the 7. And so we're going to shade in the regions that we didn't circle. All S are P. If all S are in 3 and 6, where are they not? There's nothing in 2, and there's nothing in 5. Now, we look over here. Did the conclusion shaded in 2 and 5? Did we shade in 2 and 5 over here? Yes, sir. And so this argument is indeed valid. And hopefully you see how what we did is we began with, well, let me get this out of the way. We began with this argument right here, which is just, you know, how you would make an argument in ordinary language. We translated it into standard form. We put it into standard form. because you might have read this and like, hey, is this a valid argument? I'm not sure. And then we put it into standard form. We symbolized it. And the only reason we symbolized it is to make the diagramming easier. And then we diagrammed it. And then once we diagrammed it, we were able to see, hey, yeah, sorry, this is kind of a pain, that yes, this is in fact a valid argument. So we combined, in this lesson right here, we combined multiple skills. Hopefully you guys realize that we put propositions, individual propositions like this, we put these into standard form. We had our quantifier, subject, copula, and predicate, and both the subject and predicate named classes. We put this argument into standard form. That was actually the first part, is we had to identify, so we distilled the argument, we had to identify the conclusion, we had to identify the premises of the argument, we had to make sure that our major premise was first, our minor premise was second, and then our conclusion followed. We had to put each one of these propositions into their own standard form. Then we had to symbolize it. Put it like this: all M are P, all S are M, and all S are P, so that we could finally test the argument to see that it was indeed valid. So hopefully you see that everything we've been doing this semester has been like building, or at least everything we've been doing this semester has been building. We've reused, or we've relied on our ability to distill arguments, which is the very first thing we learned. The lessons we learned about categorical propositions and putting those into standard form became very important, as well as putting arguments into standard form and using our Venn diagrams. So in logic, it's kind of like a math class in that everything builds on the previous lesson. So that's why it's important to always pay attention and make sure you have the concepts that we're covering down. All right, we could do a lot more exercises like this, but I'm just going to go ahead and turn you loose and assign your homework. Your homework is going to be on page 215 and 216, exercises C, problems 2, 3, 5, 6, 8, 11, 14, and 15. Now, the instructions ask you to do a lot of things, the instructions in the book. I don't want you to do everything it says. In fact, all I want you to do is to put these arguments into standard form and then to determine whether or not they're valid or invalid using Venn diagrams. So, the instructions in the book ask you to determine mood and figure. That's just tedious at this point. Though when I'm going over them for the answers to the homework, I might just tell you, and it's good to be paying attention to that. But really, I want you, the key here is that you can take an ordinary English argument and then put it into standard form. Actually, the key is that you can determine the validity of an ordinary English argument. That's what I'm really interested in. But there are steps along the way that you have to be able to do. You have to be able to put it in a standard form, put the propositions into standard form. You have to be able to distill the argument, determine the conclusion and the premises. So there are a number of steps along the way. Note that some of these will require, at least I know one of them will require that you take the obverse of the premise that's involved. There's at least one of them in which the premise of the argument, the major premise, I'll just tell you, doesn't, the major term is not in the major premise. Rather, the major term gives you, or the major premise states the complement of the major term, and you're going to have to convert that in order to get it into standard form so that you can test validity. So just be on the lookout for that. All right, well, if you have any questions, please do feel free to email me and I'll respond to you as soon as I can.